Welcome everybody to another Big Brain Puzzles. This is MBW, the Megabit Warrior, and we are playing Frolic today by Nordy. Today we are playing a Sudoku with some special rules. And if you haven't seen Big Brain Puzzles, every other Sunday I play a puzzle that you guys can play as well. So in the description, this puzzle does have a link to it so that you can play. So you can either, pause and play this, or you can play it alongside me, or you could just watch me fail and see how well I do. I'm going to do very well. Less than 10 minutes today. Less than 10 minutes. Probably not. But yeah, we're gonna go ahead and do this one. I'll go ahead and go through the rules because it's not like normal Sudoku. Obviously, we don't even have any numbers on the grid right now. But let's see what the rules are. So normal Sudoku rules apply. So meaning, in a row or in a column or even in a grid, the numbers 1 through 9 are in there, and they do not repeat in a grid, row, or column. There is also region sum lines. So these are the box. So box borders divide each blue line into segments with equal sums. Different lines may have different sums. So yeah, okay. So there's like 2 lines right here. So what that means is the sum of these 2 equals the sum of these 3, because there's that bold line right here. Anytime it goes through a box, that splits out and divides the line into the sum. So in other words, these 2 is equal to this one. That's equal to these 2. That's equal to these 2. That's equal to this one. That's equal to the, and so forth, right? So that's the region sum lines. Now, German whispers, adjacent digits on each green line must differ by at least 5. And that's it. There are 3 rules, and now we're just going to go ahead and get to solving. So let's go ahead and get our timer on the board, and let's do this. Play it well. All right. So first thing I want to do is I'll notice right here that this digit is a standalone when it crosses the line. So this at least we know that the sums of all these are going to be the digits 1 through 9, because we know that there are those ones right there, right? The other thing that we know is that because the German whispers are adjacent by and differ from at least 5, that means we know that a 5 cannot be in these green lines. So in fact, we know that the 5 is going to be in one of these 2 places. It would be cool to know if it was going to be in here, because then we would be like, oh man, it's going to be in here and here and wherever all the 5s are. So but we don't have that information just yet. So let's see. So 5 can't be seen here. So 5 is going to be here. So if this is 5, this definitely can't be 5, in other words. Let's see what else. So if 5 is in this row and 5 is in this, that means 5 is down here. All right. I think that's pretty much it. I'm going to make this a particular color just to remember where our single digit ones are. Because if that's the case, we know that the single digits are going to be somewhere here. So if you notice, because the single digit can't be added to anything to equal itself, because then that would be like, let's just pretend the pink one is 5. 5 plus 1 would be 6. So obviously that means this can't be pink. So this is going to be pink, which means that's going to be pink, which means that's going to be pink, which means one of these are pink. Which means one of these are pink. Okay. I was trying to see if this was going to show us like whether this is going to be 5 or not. But the green line, at least, like the 5 could still be here, in other words. So that still does check out, unfortunately. Let me see. So 5 was here. Yeah, still doesn't show it. So okay. All right. We're gonna move on from that. What we do know is no. I don't wanna assume. Okay. So I still feel like because of how clean this is coming along, that 5 is probably important in this realm. In fact, let's just pretend it's 5. If this is 5, what are the only digits that could add up to be 5? It'd be 4 plus 1 and 2 plus 3. So let's just pretend that these 5s are legit the pink one. That would mean that every single one of these, I'm going to label them just so that you can see it, would be 1, 2, 3, and 4. Now, reason why I did this is because is it possible to have them on a line? Like I'm trying to see if there could be multiple, like more than 4 in a row, more than 4 in a column, or more than 4 in a grid. But it actually looks like it syncs up pretty dang well. So actually it can be 5. That's checking out pretty well. Interesting. Huh. What I'm going to do next is going to make things complicated. No. Because we know that it has to, like, if it is a 5, it has to go 1 plus 4 or 2 plus 3. That means that if this is our 4 plus 1, that means these two would have to be our 2 plus 3. So anything that's summing with it is that opposite end. So in other words, this would be those green ones. These would have to be the blue one because green can't be here because then there'd be another green here. This would be green. Man, this is all matching up. I was gonna say like is this able to? Oh wait, check this out. Check that out. This breaks it, I think. I'm gonna have to think this through one more time just to make sure that it's not possible to go the other way. Oh no. Wait up. I did that logic wrong. Yes, it's true. I was assuming that this had to be that this couldn't be green. Actually, it still can't be green. Because again, if this is green... Oh, no, wait. I'm thinking of that the opposite way. This is green. That means this is green. And then these ones would be blue. That actually works. Dang I was thinking about the wrong way, because I was thinking that if this is blue, I think I was overthinking this puzzle a bit on that particular set. Huh. If this is blue, these would be green, which would make these blue, and then these green. Yeah, this is all working. The interesting thing is that this could be either one. Like, it works if either of them are green. Like, the other one could be green, the other one could be blue. So I don't know that way. However, can this be flipped? Like, if this is green, this would be blue. This would still be blue. But then all these would be different. Yeah, because if these were green, that would be blue, green, blue. I can't believe that worked. So 5 can still actually be in here. Huh. I was thinking that was going to break the entire thing, and it did not. It worked out so smoothly. Well. Okay. Let's go back to the 5s. We still don't know if this has to be a 1, 2, 3, or 4. Like, we still don't know. Like, because again, if this is 5, dang, it works so well. I'm going to leave those coloring and those pencil marks in it for just right now. I know, again, that it doesn't need to be a 1, 2, 3, or 4. This is just in the scenario that we think that that's a 5. I was seeing if the 5 was not going to work, but this still works, but it's not proven to be a 5 yet. So what we're going to do now is we're going to label the German whispers. The reason why I want to label the German whispers is I just want to see how many odd and how many even could there possibly be. So let me see. I'm going to go from gray to dark gray just to see, what realm it's going to go in. So this is the longest line, so I'm just going to go ahead and follow it. So if this is gray, this would be dark gray. In other words, it's 5 different, so it's going to go low to high or high to low, and it's just going to go back and forth. So if this is high, this is low, this is high, this is low, and it's just going to keep on doing that. But we know that it can't equal 5 because, again, if it's 5, 5 away from 5 is 0, or it's 10. So obviously, again, it can't be 5. So anyways, we're going to go gray, dark gray, gray, dark gray, gray, dark gray, gray, dark gray, gray. Okay. What I wanted to see right here is exactly what I see here. We know what we know is there's 4 dark ones here, and there's 3 here, and we know that there's going to be a 4th one here. What I'm trying to find out is because there's only 4 highs and 4 lows, that means the rest is going to be opposite of this. So in other words, again, because this is 3, and we know 1 is going to be here, and I'll just label that. We know one of them has to be a gray or a dark gray. That means we know that the gray is actually done. So that means this is a dark gray, which means this is a light gray. And then since we have 4 here, we know the other dark is going to be somewhere here. We don't know if like the 5 is going to be there. Sorry if I'm like, I need to at least like show you colors of like potential 5s. Hopefully this is not confusing. It's making sense in my head, but hopefully this is not like going like total off base on here. But anyways, so because we have the 4 here, that means this can't be a dark gray. It has to be a light gray, which means this is a dark, and then this is the light. I mislabeled it, sorry. All right, light, and then dark. Okay, so what I wanted to see is here and here. I wanted to show, can this ever be a 5? No. Oh, wait. Sorry. Pink does not need to be a 5. But can this ever be a pink? That's what I'm trying to say. Okay. So because all the gray is here, we know that this is pink. So if we're saying that this is pink, this would be a gray. Like, and again, right here it shows it the same way. This pink is gray. So that means this pink can never be these because we know it's a dark gray. In other words, it's opposite. It's not going to be a high. Like if it was a high, it would be a low. So this is not our pink. So we know that the pink is actually going to be here. what that does tell us is that it still can be a 5. I was hoping that it was going to show us a little bit more on like what can it be, but like honestly, yeah, it's crazy. All right, let's see what else it shows. So we have 3 grays, so that means one of them is going to be here. Like we know that this one's dark right here. Okay, so we know that there has to be 2 grays here. One here, one down here. Dang, that doesn't help us at all. I wonder if we still go back to the scenario that is 5, for example. Can we say, since there's like all these numbers are low, let's just say. In other words, if these are actually 1, 2, 3, 4, 5, for example, if these are all adding up to 5, that means these are the low numbers. So if that's the case, are all these numbers, is it possible to be a gray or a dark gray? So if I'm looking at this, and I'm just looking at a row here, or this is a good one, a good example. This gray has 3 in the row, so that means in the column, I mean. So in the column, there's only a possible one more gray that there can be. So thus, it can't be a low. The grays can't be low because it's already seen too many. Now, can the dark gray be low? Well, we just said here this could be 1, 2, 3, 4. So that does work. Here it can be 1, 2, 3, 4. So that does work. 1, 2, 3, 4, and then it wouldn't be there. It would be here. So that works. That actually works. So it's looking more and more likely that these are dark gray. And I think I'm going to mark. I actually think I'm going to mark them gray, dark gray. And I'm doing that only to continue this route of if it's 1, 2, 3, 4, does this work? So let's go ahead and make it dark gray. Man, those colors are brutal. I almost feel like I should just take off the green and the blue. Should I? I'm gonna leave it for right now. I'm sorry if I'm hurting your head with all this. I promise I'm gonna clean it in a moment. But anyways, what I was gonna do was, when you have, because again, anything that has a dark gray, I'm gonna consider that, hey, in this scenario, it is gonna be a dark gray. So we have 1, 2, 3, 4. So that means, because the 5 has to be here, the rest of these are gray. So that means we have 1, 2, 3. So that means there's going to be 1 gray here. Actually, I think this solved it right there. Or at least is telling me something. Here's another fact on can this be not a 5? If this is our 5, that means this would have to be the high number. So all the pink would have to be the high number. Or I'm sorry, low number. I think there's another way of explaining it, but let me just tell you what I was going to say, and I just saw something else too. But anyways, I'm going to stop saying high number and low number. If this is dark gray, that means this pink one would have to be dark gray too, but I just showed that this is impossible. Thus, the only way that this can work is for it to be a 5. Now, we have these dark gray seeing this one. So, if this is actually the grays, like if it is equal to 5, that means this one can't be. So this would be the 5. So it does work with it equal to a 5. I still don't have it proved though. I feel like I need more in order to prove it. Ugh. Why can't I prove it? All right. Anyways, let's get rid of that. Get rid of that. Okay. So we know that would have to be equal to that. Okay. All right. Let's because we still don't know if this is true, because again, this would be true as long as we know that these are the 1, 2, 3, 4s, and this is the 5. So if it is the 5 and the 1, 2, 3, 4s, yes, this is all working out, but we still haven't proved that fact. So let's label the rest of the grays and this. So here we have 4 in here. So this are going to be our grays. Still the grays. 2 gray. Since this is gray, we're just saying it's a high number, like a higher number than these. These are also gray. That means one of these are gray and one of them are dark. This might be interesting. This is crucial, I think. I'll continue going. But anyways, this one's dark because of this column. don't know yet how that's going to go. We know one's here and one's here. Don't know which one it's going to go around. I think the rest of them are like this. I don't know if I want to label all those. There's one here. Could be there. We at least know that there's going to be one here and one here. Oh, wait. So if this is... If we know that... Oh, no. Okay. All right. So, what I wanted to show here was, can these two grays be high? And the answer is no. Because if they're high, let's just say the minimum is 6 and 7. So if these two are 6 and 7, which make this one like, what's the minimum it can be, right? Like, if this is high... Oh, wait, we're pretending that these are the low ones. Okay. I was going to say, they can't be because they have these... No. Okay, so... Okay. I was trying to look to see if anything... Because I still haven't proved that it's 5 yet. I proved that it's very, very likely. Okay, so again, we're pretending that this is low. for right now. If these two are high, 6 and 7 is the lowest one, 13, and lowest 1, so that means this would be a combination of 14. If that's the case, I'm just going to label it here just so that you can see it. 6, 7, and 1. That means that these would be high. And if that's high, then these would be our other highs. This is what I want to show. This would be blue. Because in other words, these dark grays, this is always gray up here. Meaning these are dark grays. Because we have the green here, these would have to be blue. Because of that, blue would have to go here. Meaning this is our gray, our dark gray. So dark gray has to go here. Because both blues have to go here, that means only one can go here. I mean, that checks out already. Yeah, that checks out already. So that still works with 1, 2, 3, 4. Back to my original scenario. I was trying to prove that if this is 6 or 7, that means this would be 8 and 9. So this is 8 and 9. Oh, no. We can't have two high numbers equal this. Oh. I have to go backwards a little bit. I think I know how to prove this a little bit. Okay. Backwards. Okay. These pink ones is either going to be 5, 6, 7, 8, or 9. Okay. Can't be anything more than that because, again, we have to have multiple things that equal that. Now, is it possible? Again, this is all working with 5. Everything that I made marks on. But is it possible that one of these can be high, one of these can be low? That's the real question. So if that's the case, we know for sure that these are dark down here. These ones are light. And so these ones for sure are light. We know that one was here. Man, I don't want to like lose the coloring, but I also don't want, because I can show it. I can show it. Again, these are light. So there's 3 in here. That means one of these had to be light gray. If it's not equal to 5, that means it's going to toggle. Like, this is going to have a 6, 7, or 8 in here. So if it had a high number in there, where would the high number go, in other words? So if we already had this... Man, I'm going to have to do another color. Dang it. Okay. Ignore the pencil marks because I'm going to kind of show at least high and low wise. So gray, we have 3 here and 4 in here. So that means this is going to be our dark. I'm going to put the dark as a red. And so the vice versa is going to be the light. Yeah, that's the way it's going to have to be. Okay, so that means we have... Yeah, because now we have 4, so then this one would have to be our dark. So 1, 2, and we know that there would have to be 1 here, 3, and somewhere here 4. Hmm. We know that if this was not 5, this would have to be dark. Because all the grays are taken. So that means this would be our 5. Oh my god, we have to label 5s then. Oh, oh god, this is going to be complicated to show. Dang, and I need to show it. I need to show it this way too. That's unfortunate. Okay. This is gonna be messy. Okay, so we have the 5 here. Wait a minute, wait a minute. Did I do something wrong already? I need to go backwards a little bit. Sorry about that. So grays we know are here, right? That's what I did wrong. Okay. Dark grays we know are here. Okay. I need to label this one as a high. So in other words, wait a minute. I could have proved this a long time ago. Let me bet. I swear, once we can prove it's 5, it's gonna be like so good. I think it's here. Okay, dark gray. That means there's 4 of them. There can no longer be any more dark gray. We know that for a fact. But the gray, we at least don't know where it is here. So it could be right here. So in other words, this could be a gray, right? However, since we know because of the toggling, we know that 1, 2, 3, and then this is here, we know that this has to be a dark gray. And we know that one of these could be a dark gray, right? However, we just said that this could never be a dark gray at all because of that, right? So that means if this is not a 5, I'm going to say that it has to be a gray, because we're going to say it's a high number. And so if that's a gray, that means this would have to be a gray. But we already said that we had 4 grays in here because there's 1, 2, 3, and then there's one that's going to toggle. So that means this can never be a gray. So again, because these 4 dark grays see this, can never be a dark gray, which we know that this number is the same as this number. And then that wouldn't compute, in other words. What just came to my head though was this was also a potential, wasn't it? Like this one right here. Yeah, wrong color. I don't like that I have all these colors. Okay, these two right here potentially could be, oh, that's why. Let me just do it like this so you guys can see it better. These two, I can't remember if I removed the color, if I proved that it can't be a 5, or I just can't, or I proved that it can't be the same color. So let's double check this and verify this. So if this is gray, what is this? It still has to be a dark gray because 4 grays are seeing this. Because this is still true, that the grays are in here, so this can never be a gray. It could be the pink, you know, a 5, or it could be a dark gray. But if it can never be a light gray. So in other words, this can never be the pink. Okay, good. So since I verified this one can't be it, and then I verified this one can't be it, that means in conclusion, these are our 5s. My God, I should have stuck with just trying to solve the 5s for a little bit, because I could have went around and actually solved that a lot quicker than we did. So apologize about that. But what's good news about that is that we now know that all the dark gray is indeed a 1, 2, 3, 4. So in other words, these are the ones that we proved, right? Yep. We proved that these, we just don't know about these ones yet. These are dark gray. Oop. Let's do this. 1, 2, 3, 4. Let's get rid of some of those. Okay. All right. So we still have some questions on whether, you know, which ones are going to be the blue ones and the green ones, but at least we can make it a little bit cleaner here. So we know that greens are taken here. Yeah, blue, green. We still don't know if this, like, which one of these is blue and which one of them is green. And we still don't know because of this either, so we at least know that there's one of each in there. So, but anyways, this means that these are blue. These are green. Since that's seeing that is checking out that it's blue. And we know that one of these is going to be the other one, but we don't know which one it is. And we still don't know here either. Dang. I guess we can also label that these are going to be 3, 7, 8, or 9. Because that's the case, I know the ones that are not on at the end can't be a 9. So let's get rid of the 9s here. Or sorry, 6, I mean. Dyslexic, apparently. Because if it's 6, let me just explain it. If it's a 6, the only number that it can be away from 5 is 1. And so 1s can't be in the same row right here. 1s would be in the same row. 1s would be in the same row. So basically these ones cannot be a 6. Same as right here, can't be a 6. And in here, the ones that are in the middle of these can't be a 4. This one can be a 4 because if this is a 4, the 9 can be in 2 separate places, so that actually is okay. This can't be a 4, and this can't be a 4. Because, again, that would make that 9, and then that would make these 9. So 4 can't be there. However, we have a 1, 2, 3 right there, so this is our 4. And since we know that this is blue, that means the greens are a 1, 4. and the blues are 2 3s. Accidentally. I meant to do it one at a time. Okay. All right. So we know the 1 has to be here, meaning the 1 can't be here. And again, I know this because of that. So no 1 in here. No 1 in here. We know the 4 is here, so the 4 is not going to be there. Well, we know the green ones are 4 anyway, so let's clean up the ones that we know are not 4 ones. So we know that this is the 1, this is the 4. This is the 4, this is the 1. Okay. All right, so where are we at? We know that the 1 is going to be somewhere right here, which means the 4 is going to be somewhere right here. Get rid of that pencil mark. Can this be a 7? Oh, wait. The 4. The 4 right here shows us that these are both 9. So that's our 9 over here. Clean up our pencil marks. Excellent. So this is a 6, 7, or 8. If this is a 3, that means one of them would have to be a 9, because you can't have 2 8s on the same thing. So this can never be a 3. So meaning our 3, oh, I was going to say is up here, but this can be a 3 as well. Okay. That's fine. If it's a 2, it can still work here, so that's okay. But this can't be a 4, because then it would be here. Meaning, since there can't be a 4 anywhere here, that means this is our 4, 1. So let's get rid of that. So this is indeed green. So let's get rid of the blue. Since we have the 1, 4 here, that means the 1 can no longer be here. So this is going to be our 2. This is going to be our 3. That means this can't be our 6, because then it would have to be a 1. So our 6 is going to go here. We don't know yet which route that one's going to go in, but it cleaned up a little bit. So I'm going to go ahead and do my thing over here. Ooh. Okay. Let's get this. This is a 6, 7, or 8. That will clean up in a bit. That means this is going to be our 2, 4. Just cleaning up some things right here. So since this is going to be a 2, 4, this could never be a 2. So this is going to be our 3. That's going to be our 2. We might need to solve this in a bit. We at least know that this is going to be a 6, 7, or 8. Actually, the rest of these are going to be 6, 7, or 8. If this is a 6, that means this is going to be an 11. We know the 2 and the 3 can't be there. Interesting. I'm just going to pencil mark a couple things. I want to get rid of like all the other colors. Clean it up a little bit. Boom, 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 boom. Okay. So, where am I at? Where am I at? One, two, three, four. Yeah, these are going to be 6, 7, 8. I think this is our 9. Yeah, that's our 9. 9 is going to go up here. Actually, I'm just going to label all of the possibilities and not just keep it straight to that. One of these are going to be 9 as well, so I'll just label all of them. Same thing here. So 9 is going to go somewhere here. We don't yet know which section that's going to go in, so I'm not going to bother with that one just quite yet. What about... Oh, check this out. Since these are all dark, that means these all have to be gray. So that means there's one more gray here, and then 2 more. So that means our 4 is up here, in other words. Oh, wait, we could have did Sudoku to solve that. Either way, that proved it double. We double proved it. But what that means is that this is going to be our 6, 7, 8, or 9. And I know that the 6 and the 9 are seeing that. So that's going to throw that down a little bit, which is good. And what I don't know is which high number is going to go here. And I don't want to, like, have to label it, so... Yeah, I'm just going to leave it there. If this is a 1... Let me think about it one more time. Two 3s do have to go there. I guess let's just label these 2. I almost want to just get rid of all the coloring, because I don't know if it's relevant anymore. Because we know that... Should I label all of them? I'm just gonna do it. I'm just gonna do it just so that we can kind of show all the values so that you can see them when I recolor everything. And again, I'm going to remove the 9s in just a second. So this could be like almost anything. I'm just going to label them all, and then I'm going to remove the ones that it can't be. Okay. All right, let me remove all of those things just so that you can see, because I think it'll be visually more acceptable when we're looking at it this way. Okay. All right. Let's go here. 6. It only works when there's a 1 here. Yeah, oh yeah, so 4 and... because 4 and 9 can't work, so this is always a 1. Okay, there we go. See, now that I can visually see, oh, wrong number. Now that I can visually see it a little bit more, like, yeah, it's way better to see that. I meant to get rid of these pencil marks, just so that's more cleaner. All right. All right. Should be clean now. Okay. So if this is a 1, 6, 7, or 8 can work. So I'm going to go ahead and leave it. Okay. So this can't be a 3, because if this is a 3, that means a 9 would have to be there. So this is our 2. That's our 3. I'm just going to do a bit of... I keep on writing the wrong one. I see the 2. I'm sorry. I'm trying to go fast. Too fast, I think. Okay. Okay, that's better. Okay, so here, this can't be a 7 because this 3 sees that. So this has to be an 8. Five away from 2, that can't be a 6, so that's a 7. That works with the 1 right here. And then that kind of finishes this right here. Awesome. Okay. All right, let's clean up our penciling. All right, this looks good down here. It like we at least got the bottom. Now we just need to kind of form up now. Okay, so oops, I meant to get rid of all these pencil marks. I don't know why they're still here. Okay, so if that's a 1 and 4, then this would be a 2 and a 3. That works still. If this is the 1, that would be the 2, 3, and that would be the 4, 1. Okay, it all works. Okay. Hmm. Six. So if 6, yeah. Okay. So highest that this can be, or lowest that it can be, is 3 plus 2 plus 6, which is 11. This can't be a 1 because then 1 plus this can't be 11 because it would have to be a 10. So this can never be a 1, which means this is our 1. And this is going to, I think this is what's going to solve everything from here, which is great. Okay. Back to what I was doing. All right, so this is probably going to solve everything. So this is our 4, meaning this is our 2, 3. Oh yeah, see, it's coming along. Actually, let me just skip ahead. I'm not going to clean anything up. I'm just going to go and solve. Everything will clean itself off. Yeah, this is going to flow quite well with each other. Okay, now I'll clean it. Boo, boo. The 8s are still there. Okay. Okay. All right. Did we get that whole blue line? Oh, we did. Nice. Okay. Ooh, and then also everything else that's still here is all high numbers. Like there's no low numbers at all. Yeah, we like literally like completed this puzzle then. All right, so that means yeah, 9 can't be here, so 9's going to be up here. 9's can still go around, 9 can still go around. Okay, 9's are good. What about 6? 6. Okay, this is since this is a 7, 8. Actually, we can get rid of that 7. But this means that this can't be a 6. But there still can be a 6 here, so not totally out of the woods as far as that. Because it can go here. It can go anywhere there. This seems wrong. I'm missing a 4. Why am I... How did I not have a 4 here? What's wrong with me? I didn't like label it. So glad that that didn't mess up the puzzle. Like, oh my god, that could have been deadly. All right, back to our normal, regularly tuned program. All right, so we have the 8s. 8s are good. 8s are there. 8s are fantastic. Honestly, that means that I think that means we have to solve this up here because everything else looks good. So I think it has to do with here. Let's see. Maybe like what's can this have a 9 in it? Let's just do that. So because this is 5, it's going to be whatever this is equal to. So 5 plus 8 is 13. So that means the highest that this can be is 13. How do you make 13 out of this? Sorry, I can already tell 6 and 7. But that means definitely not a 9 because 9 plus 7 is 16. So that's way overboard. So that means, yes, this is 6 and a 7. Okay, so now the puzzle is now complete. That was a really good puzzle. I actually really enjoyed that puzzle. I think the hardest part of it for me was just trying to prove that 5 was not a 5. And what sucks is like is you can sorry, I need to like think this through. Oh, yeah, it is 8. Okay. Anyway, sorry about that. So yeah, that proving that it was I meant to put 6. Proving that it was a 5 was the biggest part of what I was doing. And the thing is, I actually think I said it because we were trying to prove that this was not gray. And I proved that this one can't be gray. And because these ones were dark gray, I had proved that as well. And I could have did the 5 at that point, but I was so focused on figuring out which ones were gray and which ones were not gray, like the dark gray, that I totally forgot that we could have just figured out the 5 at that point. So kind of working backwards when I was like, man, we're going too far into this puzzle and there's so many labels of like which one's dark gray, which ones are gray. Like it was all checking out, but at the end of the day, like it wasn't going to go anywhere until you proved or didn't prove that was going to be a 5. Like that was the main focus of this puzzle. The moment that you figure out that that's a 5, everything else kind of flows. Like, of course, it's like, it's going to be challenging to figure out the rest of it and stuff like that. But like, that was the biggest part. So like, again, I probably could have shaved off about like 20 minutes on this 20, 30 minutes off this puzzle if I would have just focused more on the 5, because I can tell right in the beginning too. I even said it out loud. I was like, I think that this is a 5, and everything's checking out. But again, these puzzles are great because you can solve them logically. So I don't like guessing and just going, let's fill things in, because some people do that in Sudoku where they're like, I'm going to put this and I'm just going to go. No, the fun part about it is logically trying to figure it out, because once you logically figure it out, it just it's so rewarding when you do that. So anyways, I'll go ahead and stop right here. I want to thank you guys so much for watching another Big Brain Puzzles. Hopefully you guys did a great job doing the puzzle if you did it yourselves. Again, every other Sunday we do another Big Brain Puzzle, so join me on that Sunday. And if you subscribe if you want to subscribe. Hey, we have a lot of content here: wrestling, video game. We got video game news. Might have some more videos coming pretty soon. But anyways, thank you guys so much for watching, and I'll see you guys next time. Later.